Start recording. There we go. Today we are going to be looking at some strategies for balancing equations. So in these cases, you'll be given the equations and then you'll just have to balance them. You'll also be asked to recognize what type of reaction it is. Let's list very quickly, what are the different types of reactions? And if I did not mention it yesterday, which I don't think I did for this block, the abbreviation RXN stands for reactions. Okay, or just RXN would be reaction, RXN with an S stands for reactions. What are the types of reactions? Tell your partner. Okay, you're all sitting by yourselves. Say them to yourself in your head, unless you don't have a partner. Number one is synthesis. So you have two things going to one thing. What's the opposite of synthesis? Decomposition. That's going to be where you start with one thing and you go to two things or more. So we have synthesis, decomposition. Those are the opposites of one another. The next two types we have are types of replacement. We have single replacement. And we have double replacement. And if we want to recognize single replacement, we're always going to have an element plus a compound. Yeah, element plus a compound. Double replacement, you're always going to have two compounds. Compound, compound. And these ones are always going to be ionic compounds. There are two more types of reactions. So we have synthesis, decomposition, single replacement, double replacement, combustion. Yeah, and combustion, you should be looking for what in the reactants? Carbon and hydrogen. Okay, so you're going to have C something, H something, or you might have C something, H something. What's the other element we might have in there? We might have oxygen in there. And what is our other reactant? Oxygen, O2. So just be careful. Single replacement, element plus compound, it's not like this is also an element plus a compound, but it's a very specific compound and it's a very specific element. So don't mix up combustion with single replacement. What are the products of combustion? Water and carbon dioxide. And it's always the same. It doesn't matter what carbon compound you have. It's always H2O and CO2. And then finally, our last type, neutralization. And this is also going to be a compound plus a compound because it really is a special type of double replacement. What types of compounds react in neutralization? We have an acid and we have a base. What do we get in the product? We get water and a salt. And do you guys know what a salt is? It's just an ionic compound. Okay, that's all a salt is just an ionic compound. Okay, that's not an acid or a base. How do you recognize your acid? Hydrogen with something, or it could be something COOH. Okay, so that's your acid. Your base is going to be something OH. Okay, so we have to have our H and we have to have our OH. So those are the 5 types of reaction, or sorry, how did I go from 5 to 7? Those are our 6 types of reactions. And now that we have more of the class here, I really have to apologize to you guys for yesterday. I was so grumpy and I was like, you guys didn't do your homework and that's so terrible and oh my gosh, and like, and I banged on desks and I made a lot of noise and I was so grumpy. And I had assigned the wrong homework. I had not assigned 6.2a that I got all wound up about. I had accidentally assigned 6.2b, which didn't actually have anything. So my sincerest apologies to you all. I did you wrong. It was not your fault at all. It was totally mine. So I own that. That is just, anyway, yeah, my bad. I'm very, very sorry. Okay, so let us look at our first strategy for balancing reactions. And strategy number 1 is to use a chart. This is not required. However, it is useful, okay? So how do we make a chart? Basically what we do is we say, okay, I've got iron is one of my elements here. I've got oxygen. Why did I just make the iron illegible? That's not very helpful. So we have iron, we have oxygen, and we have carbon. And we have those both on the left-hand side and on the right-hand side. Iron, we have 2. On the left-hand side, we have 1. Oxygen, we have 3. And on the right-hand side, we have 2. And then finally, our carbon, on the left-hand side, we have 1. And on the right-hand side, we have 1. So keeping this little chart underneath can help you to keep track of how many you have of each element. Okay? Now, we're also going to use our second strategy, and we actually learned this a little bit yesterday. And the second strategy is when you have an odd number and an even number. Can you see somewhere where we have an odd number and an even number here? There's actually a couple of them. But let's focus in on this 3 and this 2. So we have an odd number. In this case, it's a 3. The even number is 2. When you have an odd and an even number, usually the best way to go about it is to find the lowest common multiple. Which in this case is, what's the LCM of 2 and 3? 6. So we're focusing in on oxygen right now. We're not going to worry about the other ones. We're focusing in on oxygen, and we're going to say, okay, if I want to have 6 oxygen, I can place a 2 in front of the Fe2O3. If I place a 2 there, now with my chart, I have to change everything that changed. So now instead of having 3 oxygen, I have 6 oxygen. But also, instead of having 2 iron, I also have 4 iron. So do you see how the chart can help you keep track? Right? And you can say, okay, so now I've got 6 oxygen on the left-hand side. Let's now make 6 on the right-hand side. So if I put a 3 in front of the CO2, that's going to give me 6 oxygen. And that makes my oxygen the same. Okay? But putting that 3 doesn't just change the 2, it also changes the carbon. So instead of having 3 carbon, we have, 1 carbon, we now have 3. And this could be a big problem, except for that, guess what? Iron is on its own here. And that's actually one of the other little strategies, in addition to use a chart, in addition to odd and even, use the LCM, is put coefficients in front of lone elements last. Okay, so lone elements last, because if I put something in front of the Fe, like say I put a 2 here, it doesn't mess anything else up. It just fixes the Fe. Well, it doesn't, because I shouldn't have put a 2. I should have put a... What should I put here? I should put a 4. Okay, 4. Okay, and that gives me the same for my iron. And then finally, for carbon, once again, we have like a single carbon here on the left all by itself. And so we can just toss a 3 in front of that, and that gives us 3 carbon. And now I've got 4 iron, 6, 6 for oxygen, 3, 3 for carbon, and everything is balanced. And I've kept track by keeping those underneath that little chart. But like I said, the chart is not required. If you can do this in your head and you're getting it correct, I don't care if you use the chart. Okay? So that's strategy number 1. Strategy number 2 is the even and odd atoms. This is just what we already did. I think I just put it here so you would actually have it written down somewhere. So we have the odd and the even numbers, use their LCM. So how about you guys try questions 1 and 2 here. So what you're going to do is you're going to balance them. If you want to use the chart, you can go like this. You can say, okay, I'm going to separate my reactants from my products. I got my Ks, I got my Cls, I got my Os. And then you're also going to decide which reaction type do we have here. Okay, so give those, at least the first 2 a try. And then if you want to, you can carry on and do 3 and 4. Hi. What's that? We have a new book. Let's grab you a new book. Oh, it's over here. Sorry, I moved them this morning. Good. Well, I think the raise up. Okay, so, I'm on 6 of the pages, so, right? Here about 2. Yeah. If you've done number 1 and 2, you can try number 2 and 3. I'm just gonna come around and make sure you guys are getting it. Yes. Oh, this is enriched for starters. And it's just so people recognize what it's for. Right? Yeah, yeah. Memorization of all the common sense, right? Nickel. Yeah. We don't need it. Yeah. Yes. Yeah. Yeah. So we have H. Yeah, so you'll have we're starting with 2 minus, right? Yeah. 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 It's not usually recognizing the thing that we're not.
After like that.
And we'll talk about that a little bit more later. Yeah. Yeah, it is. It's just, specific roles of masters in face rather than. That go okay? Okay, good. Fantastic. All right, how'd it go? That looks good. Yes. Okay. All right. We're going to move on now to a few more strategies. You guys seem to be doing pretty well with that. Please feel free, if you did not finish 3, 4, and 5 and you found it a little bit confusing, to go back and do more of those. Always put a coefficient. This is on page 30. Always put a coefficient on a compound first. What that means is that you're going to put and we actually already talked about this. This means don't put your coefficients here or here until you've put a coefficient here. So you put your coefficient here first, and then these ones will go after. So here we have, what kind of reaction is this one? We got K plus O2 gives K2O. K plus O2 gives K2O. What kind of reaction is that? Synthesis. Two things become one. Synthesis. And if we look at our little chart, we have 1K, 2Ks. We got 2 O's on the left. We got 1 O on the right. So if we want to fix something, and I want to put a coefficient over here first, if I put a 2 here, that will fix my oxygens. So now those two are the same. And that means now that if I have a 2 here, that also changes my K to a 4. And now I can just put a 4 in front of the K over there, and that'll fix my K. And now I've got 4, 4, 2, 2 all done. Okay. You could probably do this any which way because it's a very simple little reaction. But just in general, putting coefficients on your elements last, on your compounds first, will make your life easier. Okay? All right, next one. Why is it not moving? What is happening? Okay, there we go. Hey. Oh, there we go. Okay. How about you try number 6 and 7 on pages 31. 6 and 7 on page 31. Yes. What? You're done that? You can just keep going. You can read ahead. Okay, I'm not going to stop you from moving faster than I'm moving. I just want to make sure that everyone gets a chance to have me look at their stuff and make sure they're doing okay. Are you feeling good about it? Good. Let's take this one. So you can start going with it so over on this side. Maybe what you can do is, I should be able to draw a little separation between the reactants and products. Yeah. Let's see. So for this one, what I would do is I would say I have a bunch of with my. I'm going to start with my. Yeah. See how that works. Yeah. Now, here. Now, hydrogen.
Okay, yeah, I was like, it should be done at this time. Yeah, okay, yeah. Well, the reaction time is weird. It's just weird. Is it a single replacement? No, it's not like our typical reaction. Right? So what the hell is that? Yes? I. Okay. All you do is you go ahead and set in. Sulfur is S8. And right seconds. Yeah. Yeah. My challenge, trying to find good. All right. This one, okay. So I will start. Let's start with phosphorus. This one looks really weird and complicated and it's we're trying to balance in hydrogen and see how it works out. Right. Yeah. Right? Yeah. All right. Keeping moving.
Was this hard last year when you learned it for the first time? Is it like easy now? And you're like, why did I have problems last year? That's how you will feel about the mole the next time you encounter it. You'll be like, why was this hard? Okay. Strategy number 4, this is really good for double replacement and neutralization reactions. Okay, so this is one that's specifically good if you see that you have a compound and a compound. All right. Basically, what you do is you look for the most complicated compound, and this is on page 31, okay? You look for the most complicated one. What do we mean by the most complicated one? The one with the highest total subscripts. So you look and you say, out of all these 4 compounds, which one has the most subscripts? The Fe2S3, that is the most complicated, most complex. So what we're going to do is we're going to say, let's deal with the iron and the sulfur first. Everything else will sort itself out if we do that. So pick your most complex one and say, I'm going to deal with my iron and my sulfur. So we started with, if we didn't have this here, pretend I didn't have that there, we would have had 1 iron and 3 chloride, and then over on the right, we would have had 2 iron and 1 chloride. Sodium is 2 to 1 and sulfur is 1 to 3. Okay. Now, if we put that 2 back in there, because I need to have 2 irons. That gives us 2 irons, but remember that also changes the chloride, so that gives us 6 chlorides. So far, so good? Okay. Second thing we need to do is sulfur. We have 3 sulfur here. Let's try to get 3 sulfur on the left-hand side. Where would we put the 3 to get 3 sulfur? Here's sulfur. Let's put the 3 in front of that. So 3, that gives us 3 sulfur. But it also changes sodium to 6. Well, heck, now I need to have 6 sodium, so let's put a 6 on the right-hand side in front of the sodium chloride. And isn't it fortunate that that also made this one change to 6 sodiums? So you'll find in these double replacements, if you do that, everything will just work out nicely. Okay? So pick your most complicated thing, balance those first, and then it will all work out beautifully. Okay. Place coefficients. This is on page, where is it? Page 32. We've already done this. Place coefficients on the lone elements last. This is a bizarre little equation. I don't know what the heck kind of compound NaZN4 is, but that doesn't matter. We can still balance it. Okay? I'm going to separate my reactants from my products. On the left, I have 1 Na. On the right, I have an Na and another Na, so that's 2 NAs. We have 1 zinc, and we have 4 zincs. We have 2 Is, and we have 1 I. So, do we have any lone elements here? Who is our lone element? A lone element is an element on its own. In that reaction, who is the lone element? Pardon me? Sodium, there's our lone element, okay? So we're going to leave that one to last. We're going to do everybody else first and worry about that last. So don't worry about trying to balance sodium. It will sort itself out. Let's maybe start with zinc. You could start with iodine, but I'm going to start with zinc. We have 4 zinc over here, so why don't we put a 4 in front of ZnI2? That changes zinc to 4. It also changes I to how many? 8. And remember, leave the sodium alone. Don't do anything with sodium. Let's fix the iodine first. Do the sodium last. So we have 8 iodine. So let's put an 8 in front here. Okay, there's an 8. And that's going to change our sodium to 8 plus 1 is 9. Okay, so we have 9 sodium. We got 8 here, and we got 1 here. So that's 9 sodium altogether. Iodine is now 8. So 8 is good, 4 and 4 is good. And because we left sodium alone, it doesn't matter because we can just toss a 9 in front of the sodium here and we are all balanced. Okay, so if you leave the lone element to last, usually you can just fix it by tossing a coefficient on it at the end. Okay? All right, so we have strategies 4 and 5. Deal with the atoms in the most complex compound first. Place coefficients on the lone elements last. Try these ones here. Try 9, 10, 11, 12. See how those ones go. Okay, and don't be freaked out by the fact that this says this reaction type is weird. It is weird. It's not a single replacement. It's not a double replacement. It's not really anything. Okay? So give those ones a try.
How's it going, Abby? You good? Okay. What children do you have? No, sure. Okay. So for this one, the compound, so this is what that. This is not. Oh, okay. Because it makes balancing so much better. Okay, so double replacement increase. Then you have this is the organism of comfort. They swap first. So what happens is that outside ions come inside ions. Okay, so here outside ions get together. Inside ions get together. Yeah. For this double replacement, the best thing to do is find the most complex bond. That's this. So I'm going to fix the little first. So fix the little first. Yeah. Then it's nitrogen second. Now, see how it's beautiful when you get these two guys first? Yes. Okay. Now, this one, this is not a compound of a compound. So this one balance with this one. Okay, so balance your oxygen balance. Iron, the very last. Okay. Leave iron and hydrogen as long as possible. I would leave iron for the very end because hydrogen is clear, so we need oxygen first. Hydrogen. And then. Yeah, okay. Right. You're right. Right. You good? No, it's here. Only is that we were just doing a little bit of it also changed that. Yeah. This just changed. So. So. I forget. This is not the person, but so basically this one you want to balance your so yeah, exactly. So deal with your oxygen source. I don't think anything much. Yes. Yeah. Yeah, and that's 8. So this is a weird one. That's okay. So deal with your emotions first. It's fine. It doesn't matter. So it's just. And you have 400 yeah. Well, you have 3 lithiums. So now you have 4 metals. That's an odd and then. Wow, so like in 12, I didn't even know that. Well, yeah. Okay. And now we say, okay, we're going to need for aluminum, I need 3 aluminum. And you need chloride. You say here, I've got a 9 chloride. Yeah. So let's do this one. So we're gonna balance this one last. You see also there, that's good. 7 onions, so let's make these are 7 here. Now we have 714 fluorides. Yeah. And then we have to say what about now? Timing's good. Fluoride is good for these 5. And then Yes. How are you doing? Anybody got any questions? Certainly not. Yes. No. Option. Okay. All right.
Yes.
Let's keep going.
Maybe actually.
So we are now on page 34. And these are polyatomic ions. So anytime you have a polyatomic ion, this is on page 34, you're going to treat it as a single unit, but only if you have it on both sides. So if we look at this first reaction here, we see that we have nitrate on the left and we have nitrate on the right. And if we have nitrate on the left and nitrate on the right, we can treat it as a single unit. Do not take out the nitrogen and the oxygen and treat them separately. Put them together and just balance them as a group. Okay? So there are 2 nitrates on the left and 1 nitrate on the right. This is a pretty straightforward one. This is a double replacement. We've got a compound and a compound. And our most complex formula, there isn't really one, but you could either go with this one, which has a 2 on the outside, or this one, which has a 2 on the outside. Let's give ourselves 2 nitrates. So let's put a 2 here. That gives us 2 nitrates. That also gives us 2 sodiums. So now we need to fix sodium. So put a 2 in front of NaI. And that's also going to give us 2 iodide, which is lucky we needed 2 iodide anyway. Okay? Super simple. Here's one that's a little more complicated. What type of reaction is this one? This is a double replacement. When you're dealing with double replacement, find the most complex compound. Who is the most complex compound in this equation? Is it FeClO3? Is it K2CO3? Is it Fe2CO3? Or is it KClO3? It's this one, right? So we're going to want to balance the iron and the carbonate first. So our iron, I have 2 on the left and I've only got 1 on the right, so let's put a 2 here. That's going to change my iron to a 2, but it also means that I have 2 times 3 is 6 chlorates. Now that I've done iron, now I'm going to do carbonate, because that's also in my most complex formula. I need 3 carbonates, so let's put a 3 here. That changes that to a 3, but it also gives me 6 potassiums. And lucky for me, if I put a 6 in front of potassium chlorate, that gives me a 6 and a 6, and now everybody is equal. Okay? All right, so there are some practice for these ones. Treat polyatomic ions as a single unit. You can try 13, 14, 15. Give those a quick try.
That's on page.
35, page 35.
Yeah, sure. It's either this one is or you know over is part of it. This is yeah. I would just. Because probably just are we seeing some so you can balance your lead, you can balance your nitrogen. Yeah, that's kind of what
Oh, yeah.
I'll ask you today. NH4. NH4 there's not eight. My grandmother, right? Is that the most complicated one? No, she's the most complicated. There we go. We'll start with that. Yeah. What should balance talking about? Oh, you're talking. Yes. Should be balancing the balance these things first. You balance calcium first. Balance your core. Not scrolling charts. The chart. I started with NH4s, but now I have 6. But the I have 1 NH4. And then I can see, oh, how did balance go? Yeah. Right? So that's why you might want to do it part just so you can see what you're missing. Yeah. Or hang on, which was that's good because
Okay. How are we doing? Questions on this side? You good? You good? How are you doing? You good? Good. How are you guys doing? Good questions? You're good? All right. All right. Next strategy. This is actually quite a useful one, and it's used for neutralization or single replacement. And this is on the bottom of page 36. So if you have single replacement, or if you have neutralization, and you have water, H2O, do not leave it as H2O. You're going to rewrite water as H and OH. You're going to balance your H's separate from your OHs. You're going to treat OH as a group. So if I were to have Li plus H2O gives LiOH plus H2, I'm going to replace H2O, with HOH. Now I can say, all right, I'm separating my H and my OH. On my left-hand side, I have one hydrogen and one hydroxide. On my right-hand side, I have one hydroxide and two hydrogen. So I can fix that by putting a 2 in front of the HOH. That gives me two hydrogens. That's now balanced. But it also gives me two hydroxides. All right. Now I can say, now I need to balance my hydroxides. I need to have two here, so that means I'm going to put a 2 in front of that. That gives me two lithiums. And then if I put a 2 here, that gives me two lithiums. But by separating out the hydrogen and the hydroxide, my balancing becomes much, much easier. Okay? This only works for single replacement where you have water and neutralization. Do not try and use it for combustion. It does not work. Okay? Let's try this reaction here. You should get good at this. What type of reaction is this? This should be on, I think, page 37. Yeah, top of page 37. What type of reaction do we have? That is neutralization. We have a hydrogen at the beginning. That's an acid. We have a hydroxide at the end. That is a base. By the way, could I write it base plus acid? Would that be okay? Could I write it as FeOH3 plus H2CO3? Would that be okay? Yeah, you can switch reactants around and it doesn't matter, okay? So if you've got neutralization, you should look at that water and say, hey, water, I want you to not just be H2O, I want you to be HOH. Okay, that's going to make balancing a lot easier. So now I have my H and my OH, and guess what? Now I have a most complex compound. Because you know what? Neutralization is just double replacement. Okay, it's just a special double replacement that has an acid and a base as reactants. So I can still use that rule for neutralization where I find my most complex compound and I say, oh, I've got an Fe and I've got a CO3, so I'm going to balance those ones first. So my iron, I have 2 iron on the left. So let's put a 2 in front of the iron on the right. That gives us 2 iron. That changes my hydroxides from 3 to 6. Okay. Now, after I've finished iron, I want to balance my carbonate. I have 3 carbonate on the left. That means I want to have 3, or sorry, on the right. It means I want to have 3 on the left. So that changes my carbonate to 3, but it also changes my hydrogen to 3 times 2 is 6. So 3 and 3 is good, 2 and 2 is good. And if I put a 6 in front of my HOH, that's going to change my H's on the left or on the right to 6, and it's going to change my OH's to 6, and now I've got 6, 6, 6, 6, the number of the beast. Sorry. No, there's 4 6s, not 3 6s, so we're good, we're good. We haven't summoned any demons. Excellent, good. All right, so there we are. So that is the little extra trick for neutralization. Make it HOH and then use the same rules as you did for double replacement, balancing that most complex compound, its ions first. All right. So you can try some of those. They are on page 37 and 38. And that takes us to the end of that. So basically what I'd like you to do is for homework, I would like you to do all of 6.2c. Finish it up. You might find that if you didn't do some of the questions that were further on in a section, maybe they're a little trickier. Okay, make sure you can do those. I know some of you are working ahead because you're like, wow, this is easy. Why was it hard last year? It's so easy. Just feel free, work ahead. It's all good. Okay, no problemos there.
Okay, so what do you do is say my element is a metal. So it's single metal. You look at the reactant and you say if it's metal, it's single versus metal. So this one is metal, yes. This side, non-metal. Although actually when hydrogen's involved, hydrogen's a little bit more. Okay, so I would think about it as a metal non-metal because hydrogen. So hydrogen makes those and it's not really important to get to predicting products, whether it's metal or whether it's not metal, because what I get is people trying to let's just say let's see this one. Okay. Mostly by phone. No, please don't. Okay, basically it's just like you cut a metal element, you have to replace the metal with the compound. Yes. Yes. Weird just means that it's not one of our standard 6 types of reactions. There's lots of other things in reactions that aren't those 6. Yeah. Okay, so I would probably start with something that's not Li.
Yeah.
And hope Li works at the end.
Yeah.
Right, so yeah, starting with chlorine is smart, and then maybe start with hydrogen, right?
Yeah.
And then after that, you can let it be like, then you're just now you can say, okay. So it's already sort of. Oh, that too. Yeah.
So you do very much more than that.
People are going to go, yeah. 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 So when you have those complicated ones, you're like, I don't know what to do, now I can solve it. And then be like, I'm gonna get a whole, something. Don't worry about there is none. And this is single replacement anyway. So you can do. Oh, in general, it's one of the most subjects. So this one, subject 3, and this is subject 1. So subject 2, subject 5. So 3 and 2, what else you want? Yeah. Yeah. It's not as bad as you think.
No, but like all of them are together.
Yeah, but it's by itself.
No,
So right there again.
yeah, like,
Yeah,
yeah.
that's okay. That's okay. We go there. CD7. That gives me 14 fluorides and 1400. That's the whole thing about balancing. Don't panic. And now. Yeah. Yeah. So my concentrate anyone doesn't. Oh, that's not right. No. I've got most of the whole body brain mix. And I have a couple people still doing this one, but they're also doing the same. Yeah. So. Right. I want to. So until we decided to switch to mouse concentrating. Yeah. Yeah, like, so I'm like, seriously, for a while, I was like, yeah.
Hi.
Don't give me my brief sheet.
Where are you? Amir, where are you? No. No. Where are you? I had it. Are you in with my block 8? Did I mix you up? Or have I hidden it? I've hidden it. But you got 32. So you're good.
I got the full mark?
Yes.
Thank you.
I don't know where it is, but I know what you got. So you're good. Yeah. I will hopefully find it for you for tomorrow so you can be like, oh, look at that.
Thank you.
Okay.
Last year, fish bowl allows. I'm gonna add word. Why? Oh, really hater, dude. Hey. Oh, bro. That's tough, bro. I would for a one. Wow, bro.
Did we really know that? My connection.
Ow! Bro, I should have done more touching.
No, I just obviously don't even sleep anyway. It's not split. I just watching Rogue One. And imagine last Star Wars destroying Scarab. And it's like, oh shit, my sleep.
I'm waiting for that day.
Like I don't like it's the same part.
I am.
Star writing test today.
Well,
you know.
Come with me.
Eric, yeah. What's unit 6?
If you were Jack and Jill, I put it. What the hell? Stay here for I learned that the C plus X is the syringe. Oh my goodness. Yo, chill on the. Yo, bro, doing too much, bro. And like, we're back. Taylor, stop it, Taylor. Now you're not catching you up. No, you're not catching you up. No, yeah. No, you don't. No. I can't break. That's what I'm saying twice. Okay? Now, don't do that. Taylor, don't do that. Taylor, I'm there doing more. No, Taylor. You're going earlier. No. You have no excuse. You can do any exams. It's your test. No excuse.
Okay, who else am I missing?
Look, look. That's a bad student. It's a good student. See, Taylor, I did everything. I did even for the days I was like not in the class. See, Taylor. See, Taylor. I'm a good student. You're not a good student. Wait, Tranya, who made the first move? Be honest.
All right, friends. Today we are going to be on page 30. 30. Oh, no, sorry. 28. 28.
Nothing more. There's 28. Almost.
Okay, page 28.
Wait. Did we get our test back?
No,
Okay.
we're getting close.
Wait, did they get their test back? The other ones?
Huh?
Did everyone get their test back?
No.
Oh, okay.
No, basically, if you want to know your mark, you can check on my ed.
Oh, you checked.
It is up there.
Okay.
Okay, and if you got below, did we talk about this yesterday? If you got below 70%, 70, you can come and do corrections with me to raise your grade up to a maximum of 70% for half marks on whatever. Okay? And if you want to do corrections with me, even though you got above 70%, that's fine. It just won't count for anything, but it will count for your learning, which is amazing. Hi.
Hi.
What can I do for you?
The new book.
The new book. Yes, it's over here. And I'm going to have to get an answer for you tomorrow because. Okay. It's on Teams. Okay. Yeah, in the files.
We're starting this one today, right?
We started it yesterday. Yeah. All right. So we are on page 28. And there's a whole bunch of strategies to balance equations that we're going to learn today.